Welcome to qnawire.
So how do we determine if a table represents a binomial distribution? So there's several ways that you can do that. One way might be that you look at table B in Appendix A, and if you can find the value of n, which in this example is 3, go down to n equals 3 and see if in that table the values that are represented in the question are there. And when you look, you will see that if you scroll over to point 6, the values there match the values in the table. And that's one way that you can determine if a distribution is binomial. We got lucky on this one because it was in the table, but let's see another way that we can do that. The first thing I would do is make sure that all the probabilities total to 1. And yes, they do total to 1. The reason I do that is because if they were some really large number past 1, then I wouldn't even need to go any further because our distribution for probability cannot be greater than 1. So then I'm going to use the formula for the probability of a binomial distribution is n factorial divided by n minus x factorial times x factorial times p to the x power times 1 minus p to the n minus x power. And so I'm going to take an example here. You can use any value you want. So I'm just going to start with a 0. And I already know that the answer to this is 0.064. My n is 3, because that's my sample size. I'm doing x equals 0 here. So n minus x is 3 minus 0, which is 3 factorial. X is 0, so that's 0 factorial. I don't know my probability of success yet. And I don't know 1 minus p because I don't know the probability of success. But instead of putting x to the power here, I am going to put 0 because that's the problem I have. And then n minus x would be 3 minus 0, so to the third power. This value is 1. Anything to the 0 power is 1. That's why I chose the 0. I like to start there. Then 1 minus p to the third power. So what I have is 1 times 1 times 1 minus p to the third power. So I have 1 minus p to the third power equals 0.064. I can take the cube root of both sides, and I get that 1 minus p equals 0.4. So if 1 minus p equals 0.4, then that means that p equals 0.6. So then I could use this formula again to see that when x equals 1, I get 0.288. When x equals 2, I get 0.432. So yes, this table represents a binomial distribution where n equals 3 and the probability of success is 0.6.